Good evening. My name is Alice Knapp. I'm the CEO of the Ferguson Library, and I'm going to talk very briefly. But while I do, that gives you an opportunity to silence your phones. Mainly, I'm here to talk about the wonderful group, the Friends of the Ferguson Library. And so if this is your first time at an author event, you are now members, at least until the end of December. And I believe you're going to be tempted as to why you should stay and remain members. But I will tell you what the Friends do for us. They are the secret sauce that raises money at fundraising events like this, that then goes back into the library to underwrite some of our special programs. But on top of that, they have some special programs that they run. One of them is our Books for Babies program, which means that every child born in Stamford gets a book, which deserves an applause, by the way. That has been true since the mid-'80s, and it actually became a model program for the whole country with the American Library Association. So this is something that other communities have copied. The other thing that they do is they have a literary competition, which is for the grades 3 through 12, and many of the people who have gone through it over the years have now gone on to become writers in their professional lives. So it's a great program. If you're ever here on the last Sunday in April or the first Sunday in May, please stop by. It's mayhem because the winners come with their whole families and their grandparents and everything, and you would think they were graduating from college. It's just a fantastic program. But what I will say is that the Friends make us a great library as opposed to just a good library, and we couldn't do what we do without them. So with that, I'm going to introduce you to Denise Marcel, who is not only involved with the author series that you were seeing, but is involved with a special group that a committee that the Friends put together this past spring to help the library as we combat book challenges, and this is a national-wide problem. There's currently 38 book challenges in the state of Connecticut, so we're not immune. So they're helping us as we fight against this and for intellectual freedom, and we are the only book sanctuary library in Connecticut. So.
Thank you, Alice. I don't know if everyone heard the last point she made was that the Ferguson Library is the only sanctuary library in all of Connecticut, and it was the second in the nation. Well, we're here tonight. I'm on the Authors Series Committee of the Friends, and we're here tonight this evening to have a discussion, listen to a discussion with Dr. Siddhartha Mukherjee, and he will be in discussion with Dr. Siobhan Dolan, who is the chair of OBGYN at Stamford Health. And they will be discussing Dr. Mukherjee's Soul of the Cell. But before I get started with some introductions, I would like to tell you about the other author series that we have coming up this fall, because we have an amazing lineup. On October 5th, we have Jacques Pepin, who was here in December and filled the house and charmed everyone. On October 12th, we have Nelson and Alex DeMille, mega best-selling authors. And on December 4th, we have Lydia Bastinich, the restaurateur and chef and cookbook authors. And the Friends, one of the other programs the Friends host is a very popular pub crawl, which will be at the end of October, where you get to go to 2 different restaurants and then come back to the library for dessert and entertainment. So for this evening, Dr. Mukherjee they're going to discuss his book. And tonight, all of you, of course, received the book, but tonight is, everyone in this audience, it is your lucky night, because Elm Street Books has brought extra books and extra hardcovers, and they are selling those books, hardcover books, for the price of the paperback. So that is a great deal. Consider buying one as a gift, and it's a great hostess gift. I always bring books because everybody brings a bottle of wine, but bring a book instead. Dr. Siddhartha Mukherjee is the author of several books, including The Gene, An Intimate History, which was a #1 New York Times bestseller, The Emperor of All Maladies, Biography of Cancer, which won the 2011 Pulitzer Prize for general nonfiction, and The Laws of Medicine. He is also the editor of Best Science Writing of 2013. He is an associate professor of medicine at Columbia University and a cancer physician and researcher, a Rhodes Scholar. He graduated from Stanford University, University of Oxford, and Harvard Medical School. He has published articles in many journals, including Nature, the New England Journal of Medicine, Cell, the New York Times Magazine, and the New Yorker. And for all his wonderful contributions to science, he was awarded the 2014 Padma Shri Award, which is one of India's highest civilian honors. He lives in New York with his wife and daughters. Dr. Siobhan Dolan, in addition to her MD degrees, holds an MPH, an MBA, and an MS. And she is the chair of the Department of Obstetrics and Gynecology at Stanford Health. She's board certified in both obstetrics and gynecology and clinical genetics. She received her medical degree also from Harvard Medical School, and she completed her OBGYN at New York Hospital, Cornell Medical Center, and Yale New Haven Hospital. And she did her fellowship in clinical genetics at Albert Einstein College of Medicine and Montefiore Medical Center. Dr. Dolan is building right here in our community very innovative clinical programs by integrating genetics and genomics into aspects of care to provide personal medicine for all patients. Please welcome our guests.
We good? Thank you so much for that lovely introduction, and it is really terrific to be here. I thank everybody for welcoming me to the Stanford community back in April when I joined this community and Stanford Hospital, and I'd like to welcome Dr. Mukherjee tonight to meet with all of us.
Thank you very much.
So I thought we'd start at the beginning. Tell us about the title. What is the Song of the Cell?
So thank you very much. The titles of books usually for me come very late in the book. I start with a kind of a dummy title, and so for a long time.
What was the dummy title for this?
Well, there are many.
Okay.
It was called, I knew I wanted the word cell in, and I somehow couldn't put it in. So initially it was called The Sum of All the Parts, which is a lovely line from a Wallace Stevens poem, and it actually is one of the titles of the chapters. And then I was writing the book, and there's a final chapter in the book which talks about, people who've read the book or will read the book, there's a final chapter in the book that talks about the idea of the intercommunication between cells and how you build a body, human body or animal bodies out of cells, and how, a very old idea, but very intriguing idea in medicine is that the body is a citizenship of cells. And so somewhere along that, there's a kind of a beautiful story of a man of another writer, Amitav Ghosh, who's a great writer, who tells a story of a great botanist who goes to a rainforest. And he takes, this is somewhere in South America, and he takes someone from the local village to the rainforest with him. And this young kid, the local, knows the name of all these plants. And as you know, in the rainforest, there are thousands of plants. So, and the botanist is amazed because the botanist, of course, has never seen these plants before. And he says, I'm amazed at how you know the names of all these plants and shrubs and trees, and the young boy looks kind of dejected, and the botanist says, "What's your problem? What's the problem?" And he says, "The problem is that I know the trees and the plants, but I don't know the songs that pass between them." Um, and it's in a beautiful book. And so I wrote this, and of course, the idea was that as we understand ourselves as ecosystems of cells, we can understand cells individually, but we're still to understand the songs that go between them. And I'll give you some examples of what that might mean. Um, in the malignant world, for instance, um, we don't know, for instance, why um, some cancers only like to grow in some places and not others. So, why does breast cancer, when it's metastatic, like to go to the bone but not to the spleen? Um, we don't know the answer. This is 2023. We've been studying breast cancer, as you very well know, for decades, and yet we don't understand that. Why does, endometrial cancer like to go to the lungs, but not to any other part of the body preferentially? We don't know. And so, just like the young boy, there's still so much to be learned about the body and about these. I just gave you an example of a malignant disease, but of course, you can imagine examples in which you don't understand how and the immune system connects with another part of the immune system. That's another song that builds multicellular organisms like us, and I can go on and on and on, give you examples both from the world of disease and from the world of normal physiology, where we would be confused because we just didn't know. And so I finished this chapter, and my publisher called me up and said, "You've just gotten the title of your book." And I said, "Oh, what's the title of my book?" And she says, "It's The Song of the Cell." And I said, "Oh, finally, I've solved my problem, because I wanted the word cell in my title." And it works. Anyway, that's how the title is.
When I saw an interview you gave, and one thing you said, which I wonder if you comment on a little bit, for me as a geneticist, this idea that like we had sequenced the genome, right? We were done. We had the code, but the idea was, right, that the code in and of itself really didn't tell the story. The cell needed to process that, needed to decide how to become which cell, and to be diseased or not diseased, and that was sort of like a score of an orchestra, and then the orchestra had to play it. So do you have thoughts about that in a grander way?
Yeah, I mean, I think people often feel as if the genome is static. So if I took any one genome of any one person, it would be written in 2 billion letters, 3 billion letters, pardon me. And if you published it like a book, it would be um, around 60 volumes, 60 full sets of the Encyclopedia Britannica. So you can imagine a single person's genome sort of lining the entire uh, this entire floor of the library. Um, but what's interesting about it, of course, is that a nerve cell only selects certain parts, certain pages from that library of your genome, and if you were to use a musical analogy, plays those out. A cell in your liver uses a completely different set, and that is why it's a nerve cell, and that's why it's a liver cell. It is the fact that they're using the same. Both of them, basically, give or take, have the same library. But because they're only reading certain parts of it, you can completely change by reading only certain parts of the encyclopedia. You can completely change your identity. And that's why a liver cell is a liver cell, and your brain cell is a brain cell, and your nerve cell is a nerve cell, and so forth. So, so there again, this whole metaphor of the song, because each one is playing a different. There's a master score, which all of us have in every cell, but of course, the individual parts are individually different. And I think that's the basis for human physiology. That's how we behave, and that's how we become who we are.
Thanks. So I'll tell you a little bit of my journey. I think when I was asked to do this, I started to read your book in sort of mid-August, and I actually listened to books on tape. That's how I read it the first time, which was fantastic. And when I finished the book, I remembered The Immortal Life of Henrietta Lacks, and I actually went back and read that again. And the part that I remembered and that I read again in the second time was this scene very much towards the end of the book when the Hopkins researcher who has actually visualized a lot of cells brings Henrietta's daughter, Deborah, and I think the brother, Zachariah, and is going to show the family these HeLa cells, right? So Henrietta Lacks had a cervical cancer. It was the basis of cell culture, was a cell line that really led to remarkable discoveries. And so this family sort of lives this whole experience. Sadly, the mom passes away, Henrietta herself, at age 51. And the cell line's called HeLa for H-E, Henrietta, and then L-A, Lacks. So anyway, the story is that Henrietta and Deborah and her brother are actually now finally visualizing HeLa cells after their whole life hearing about these cells. And they're looking at the cells and sort of having this remarkable moment. And I actually took the quote. Deborah finally looks down the microscope and she says, "Everybody's always talking about cells and DNA, but I don't understand. What is DNA and what's her cells?" And so the question I pose is, how can we sort of educate patients and consumers and the public enough about cell biology and what about it so that they can actually actively participate and benefit from all these amazing advances in cell therapy?
So I think the way we educate them is again through books and teaching them about the idea of cell biology. Cell biology is extraordinarily central to all of this. People have attached a kind of importantly attached a kind of meaning to genes and genetics because of course it's very tangible. It's something you inherit, something you inherit from your parents, and there's a tangible sense that information is being passed down. Cell biology is a peculiar situation because that information that's passed down becomes very diffuse. As I said before, a liver cell and a brain cell are not like each other. So to explain cell biology, you have to really take a different kind of approach. You have to use these kinds of ideas that, there's a song that's being played out, but it's different from every cell, even though the genetics or the genes are the same. And then you begin to understand that we are these very complex assemblages or ecosystems, depending on how you want to put together. We're put together by that. And then usually I describe the idea that the gene is inert without the cell. A gene is a molecule, is encoded in a molecule of DNA. If you float a strand of DNA in space, it's nothing but a molecule, it's a chemical. A cell enlivens that gene. Without a cell, you wouldn't have anything. That gene would not have life. So the cell is the unit of life. It's not the gene. The gene is just the information that's carried as the unit of life. So, and it's harder to explain because it's again so diffuse. A bacterial cell looks nothing like, for the most part, looks nothing like a neuron, but they have many similar properties. And the final piece that I think people get excited about, and a lot of it is about getting people excited about the idea, is that everyone talks about the incredible, and it's been everywhere in the news these days. Everyone talks about the digital revolution and AI and other aspects of the digital revolution, and of course, we've done a lot of work ourselves in our laboratory on AI and machine learning, et cetera, et cetera. But it's the digital learning or the digital revolution by itself is also inert. It has, if for it to be actualized, it has to go through some living body. In other words, for it to be actualized, it has to change behavior, it has to change ecology, it has to change something about living beings. And in order to do that, it has to intersect with cell biology. with cells. And it can be at the highest level. It could be, your brain cells interacting with something. It could be actually the changes that we make in cells. It could be in the birth of new medicines, new drugs. But ultimately, all of this entire idea that 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 virtually anything we do, any activity that we perform, is ultimately has to go through the biology of cells. If you twitch a muscle, it's a cellular activity. If you heal a wound, it's a cellular activity. Most importantly, if you birth a child, that's a cellular activity. And so, um, you know, um, there was a nice review of my book in the New York Times, which says, "Well, wait a second. What is this book not about?" Um, once you start thinking about that, I mean, this book becomes about everything. So, this maybe it should be called the history of everything. Um, but in some ways, not to put a fine point on it, it is about everything because that's the way we're built. That's the way the structure of our selves is created. So, um, long answer to your question. I mean, I think a cell is the unit of life, and through life, everything is actualized through life. Information, activity, response, stimulation, stimulus, all goes through life. And so it is simultaneously the most exciting, but also the most challenging idea in science that is where life sits.
Yeah, for sure. I mean, I'm sure you feel this every day as well, but sometimes it feels like we're speaking a different language when you're talking to patients in terms of like how to get people to be able to meet you halfway, to engage, as you point out, in something that, is incredible to their, personal health and well-being. And, we want our whole public to be able to engage. So, you know, there's time ahead, and certainly a book like this brings a lot of folks around or on board and really has been a profound education. I remember thinking, I used to sit in the library for hours studying this, and now it's condensed into like 2 paragraphs. Like, I wish I had this book when I was in med school, and like mitochondria. I can remember really struggling over mitochondrial disease, and like there it is in 2 paragraphs. So congratulations and thanks for what you're doing to educate the public. I'll move on, if I may take my OBGYN prerogative in the next question. You write about blood transfusion as being such a monumental breakthrough, and what a life-saving aspect blood transfusion was in the war. And then it segues for me into maternal mortality, and hemorrhage is a major cause of maternal mortality. And the good news is we've made some progress there in this country. We have, massive hemorrhage protocols. We have hemorrhage carts. We're doing some good there. We're bringing down those numbers a little bit. But the maternal mortality crisis is really staggering. And in other ways, we see rising rates of maternal mortality and morbidity, and we also see enormous racial disparities. We see African American women, Black women, with 3 times the rate of maternal mortality to white women in this country. And I know comparably there's a lot of similarly inequitable outcomes in cancer. So I wanted to just pose this question, like, how are we as a society, how is our health system going to grapple with this and really find a way to bring new technologies and innovation to benefit all?
Yeah, what's interesting is, there's every chapter. I mean, the way the book is organized is sort of interesting. Let me talk about the book for a second. I'll come to your question. But the way the book is organized is that it's very different from my other books because of the structure. And I'll talk a little bit about writing this book, which was a very different process. Usually, when you write a book, chronology is your friend, and um, and I'm now talking about writing nonfiction or fiction for that matter. You start the story at the beginning and you end the story at the end, and there's the middle, which is carried through by time. This book refused to be carried by time, which is very hard. So instead of being carried by time, it's carried really by subject matter. And so each chapter becomes takes on the persona of a cell. It becomes the life of a cell, and it's very unusual in structure. Um, and I sort of randomly came about that idea. Not randomly, I spent a lot of time on it, um, but yeah, it evolved. Yes. All right. So the reason I'm giving you that as a background is that I think that um, the um, the idea of how to solve racial disparities, and particularly racial disparities in outcome in medicine, has finally come home to really bother people enough um, that we are trying to set about protocols to address them. There are many examples of this. A famous story is that you know um, an African American man and a white man walk into the same hospital through two doors. Both have the same prostate cancer. And this is a true fact. The African American man has lives for 5 years. The white man lives for 25. Um, and that's not always. Some of it has to do with genetics and exposure, but some of it has to do absolutely with the quality of care and the differences in the quality of care. And it's the same thing with maternal mortality, same thing with infant mortality, etc. I mean, the first thing that one does in medicine is to establish the facts. And thankfully, we have ways that we can establish those facts, and those facts are not disputable. You can't have false information about facts, although certainly you can in the public sphere, but um, in medicine, it's very hard to have false information about facts, and these are facts. These are truths. And so once you have the truths, you then have the capacity to act on them. And the nice thing about it is that it's a self-fulfilling cycle, because you then have the capacity to figure out whether the outcomes are matching what you expect them to match. So if one is true to all of this, then the general progress of medicine is to go through this virtuous cycle in which you identify the facts, you identify the problem, you create the facts around the problem, and then you ask the question, what's the cause? The cause could be, misinformation. The cause could be absence of adequate care. The cause could be economics. Could be all of those. And then you take them system by system and try to figure out ways that, in healthcare at least, you have a more equitable distribution of resources, and therefore correct some of these. This is the virtuous cycle. The interruption of that virtuous cycle is misinformation, lack of information, um, rumors, gossip, all the kinds of things that disrupt that virtuous cycle, which we are all very familiar with.
Thank you. Next question, I want to ask you to think with us about Stanford. We have an amazing group of friends here. We have an amazing hospital. When I joined here, I actually met with Kathy Szilard, our hospital president, who's fantastic, and she talked to me about innovation, like what can we do right here that's innovative? And so we're working on developing a personalized medicine center, and it sort of logically comes out of OBGYN in that hereditary breast and ovarian cancer and genetic testing for BRCA1 and 2, and then taking steps to bring down your risk if you've found to be carrier of a mutation is one of those areas that's really ready for prime time clinically. And I think that's where we want to start, and we're starting there, but that's not where we want to end. So from your perspective, like what's ready for prime time in a community? What's ready for population level personalized medicine? And what can we do here to sort of generate that excitement and be forerunners in bringing this revolution to improve health?
Well, the big advantage with in communities, when you look at it in terms of population health, is that you have probably the best follow-up and the most continuous way of treating patients. So, unlike tertiary hospital systems, where often patients are essentially lost, they come in for one visit and they go away. Communities are networks of friends. And those networks of friends can be very powerful because they allow continuity, and you can follow someone not for 1 day or 2 days, but for weeks and for months and for years. And so the power is not to be underestimated, because you can launch longitudinal studies, which are impossible to launch, which would be impossible to launch otherwise. So, I, obviously the real advantage of having a community is that everyone's trapped in a room like this, and you can't. There's only one door out, and you can't get out. No, I mean that in a very positive sense. And there's a reason that great population studies that have allowed us to personalize medicine, some of which we actually have forgotten about, but great population-based studies that have allowed us to personalize medicines were community studies. So think about the Framingham study. The Framingham study has completely changed the way we manage cardiovascular health. What came out of the Framingham study? Well, number one, we realized that hypertension was an independent risk factor for heart disease. Incredibly important. So-called silent killer. You and I wouldn't be measuring our blood pressures if it wasn't for that.
It's actually hard to think there was a day when we didn't know that.
Yeah.
If you know what I mean.
I know,
Like
it's
it's
hard
such
to
a
think that,
bedrock
right?
fact at this
Right.
point. Yeah.
But the reason that study was possible was because it's not called the Boston study, and it's not called the San Francisco study. It's called the Framingham study, because Framingham is a small, relatively small local community where they had longitudinal follow-up for years and years and years and years, and they figured out in that study how to look at risk of cardiovascular disease. And so again, I mean, I think at a place like Stanford, you play to your strengths. The strengths that you have is you have a network of friends,
And families, right? From a
families,
genetic
yes.
standpoint,
Yeah.
right? Because
And so
Yeah.
and so incredibly important, because you have a resource that no one else has, because you can follow a family or a network across multiple generations, multiple time points, and you can generate incredibly important personalized data. And I often say that personalized medicine begins with genetics, but it doesn't end with genetics. So you might find, for instance, it could be behavioral. Um, it could end up being so, and there's an incredibly beautiful study by um, professors initially from Boston and now at Yale, who have studied, for instance, happiness, um, or and they studied that by studying a cohort in a community setting and asking the question, who is happy and who's not happy. It sounds like a rather silly question, but it turns out the data are very interesting.
and I think it's the most popular course at Yale now.
Is that right?
Yeah.
Yes, it is, and it's based.
She's on to something, right?
Yes, I know. It's based, actually, that course is largely, not completely, but largely based on that kind of study. What that study showed is very interesting. What that study showed is that if you if you create a network of humans, which you can, in a community. So if you, for instance, if you map, and you can map this room as a network. Forget about any individual. So look to your left, look to your right, and look up and down, and you'll see that you'll know someone here. So you can create basically a virtual map of this community of people who are here by 1 degree, 2 degrees, 3 degrees, 4 degrees of separation. Okay, so your neighbor may be here, that's 1 degree. Your friend may be here, that's 1 degree. Your friend of a friend may be here, that's 2 degrees, and so forth. So you can create a map. And then you ask the question, and this was the question that was asked, who's happy and who's not happy, and how does that change over time? And what's interesting is that it turns out that it's a little bit like electrical circuits, if you look at this over time. Happiness is created in networks and nodes. So there's a network of happiness, and an individual usually inhabits that network. And what happens over time is that when a network starts dimming, the entire network dims together. And over time, what happens is that people who get sad or depressed or isolated sit in the peripheries of this network. They're individuals, they're alone, they're outside these networks. Similar work has been done on obesity. Similar work has been done now on access to care. And so when you talk about personalized medicine and the power of the community, you have to remember the power of the community is to enable these kinds of incredible longitudinal studies, which would otherwise be impossible in the absence of a community of people.
That's great. So let's go Stanford, right? We have a lot of great work to do. And I'm actually not joking about that, because I think the other powerful piece is to do cascade testing. So say you identify an individual with a cancer and they do genetic testing and they find that they have, like what was formerly called a mutation, but now we call a pathogenic variant. But the idea is it's a genetic change associated with increased risk of disease. But if you identify that in a family, the hope then is, and not the hope, the reality is you can test sisters, children, parents, et cetera, and identify individuals at risk before they develop the cancer. So I think the real preventive step is there. And again, I'm looking forward to implementing that here in Stanford with everyone here. And again, thanks for giving us some forward-thinking ideas. I'm going to ask one more question, then we're going to do like a little fun, fast thinking kind of question, and then I'm going to open up to the audience. Fair
Great.
enough?
I'm always for fun.
Okay. I have read books like my whole life where they're often fiction, and the kind of conceptualization is like it's absolutely predictive, like it's in his DNA, like he's this or he's that. And I was reading this weekend. It's like a Jenna's book club book. It's great. It's called Bunyan Moon by Tao Tai. And sure enough, I'm getting ready for this interview, excuse me, and here it is. And it's in many, many books, but Are Good Mothers Born That Way? Is the DNA strand an invisible one winding through the others? This notion, which I often read in fiction, I'm curious of you as well, but that it's like a genetic change and it's fully predictive. And those of us in genetics, in the genetics world and in cell biology, it's not at all fully predictive. It's quite probabilistic, and how you make your way through the cell as a genetic code is a big part of how your probability gets determined. So I'm always, it always crosses my mind, like, how did this idea get out into the public, and then the reality is quite different, and like, what should we do about that? I'm just curious if you have any thoughts.
Well, so my broad thoughts are, aside from extraordinary rare diseases, cystic fibrosis, maybe Huntington's, almost certainly, virtually most common diseases and most common traits are encoded by dozens of genes or modified by dozens of genes. Even the one you mentioned, BRCA1. Remember that most of the studies that we've looked at have looked at BRCA1 retrospectively. In other words, you have cancer, do you have BRCA1? If you look at the other way, which is you have BRCA1, do you have cancer? It turns out that not everyone with BRCA1 gets cancer, and some people may get cancer at 90 years old. Some people may die with cancer cells in their body, but never have an overt tumor. So, and this again brings me back to the idea of the community. What the community allows us to do is to look not in the rear view mirror, but in the forward view mirror. And when you look in the forward view mirror, which is when you start with the genetics and ask the question, what happens to the person over time, you realize several things. Number one is that you realize that we underestimate gene-gene and gene-environment interactions. And that's because the whole idea of genetics is filtered through the cell biology. And the cell is what's being subjected to the environment. The gene is not, right? It's your cells that are encountering whatever the environment that they're in. And so there's a big missing chunk there of information filtering. And we're missing that. So again, gene-gene interactions, that's genetic, but gene-environment interactions are extraordinarily important. So a person who may have a predisposition to heart disease or to a disease of the nervous system, premature aging or Alzheimer's disease, may be completely altering that risk based on what environment they're in. I'll tell you an interesting fact. Now that we're exploring, and then we can go to a quick fire round, but now that we're exploring a disease like Alzheimer's disease, everyone is, of course, concerned about this because we can see the prospect of neurodegeneration in our future. one thing, and there are 1,000 people who are trying 1,000 drugs for this. There's one thing that's almost certainly likely to work, and it's always worked. And it has a physiological relevance or a cell biological significance. So it turns out that if you look at the brain and you forget about the brain and you just think about the brain as an arbor of neurons, and by arbor I really mean like a tree. So a tree with a billion branches interconnected with each other, right? What happens in neurodegenerative diseases like Alzheimer's disease is that the arbor declines over time and the branches get less and less connected. It's like a tree where the branches begin to die out. The central stem remains, but the complexity of the branches begins to die out. And over time, as you look, that the branches die out. Now, what's interesting is if you look at patients who may have a predisposition to Alzheimer's disease, their branches tend to die out, and again, this is early data, so that needs to be refined. Their branches tend to die out basically on the same curve. So you can't alter the slope of the curve. You can't seem to alter, and maybe some of these new drugs will. But what you can change is where the starting point is. And if you change the starting points, if you start here and your branches die out, obviously there's a threshold, and all of a sudden, you'll be, a patient sick with Alzheimer's disease. Whereas if you start here on the same curve, you live out your life, you're on the same curve, but your disease develops much later. And then the question becomes, well, how do I change that curve? How do I change the starting point? And the one thing, the single thing that changes that starting point is to remain engaged. And to remain engaged as an elder, as you age. So exercise, social engagement, dialogue, brain puzzles, walking. I mean, all of these are independent community, dancing, meeting people, having a meal together. These are independent predictive factors of how much you can arborize your brain and thereby prevent that decline that happens so that it happens later in life. So, of course, it would be a wonderful thing if there were drugs around and, things would become very happy. But in the meantime, while we wait for the drugs, get your cells to work.
Right, let's dance.
Yeah.
It reminds me of bone density, right? Because we work so hard with women. I remember learning bone is not this firm, fixed thing. It's always, building and being broken down. And so this idea we work with a lot of women to try to get to a maximum bone density, the same paradigm.
Starting point, and then everyone declines from there, yes.
Okay.
So come to the library more often. Yeah. Read a book.
For sure.
Do something.
So I was actually going to make a segue, but you made it too easy for me. Your colleague, Paul Greengard, you talked about fast neurons and slow neurons. And so we've heard a lot about your slow neurons, or we've heard from your slow neurons so far. I'm going to do a little quick this or that for the audience. We're just going to pose two concepts, and Dr. Mukherjee will choose. It's fun. It's not don't take it too seriously. My residents helped me make up these questions. So, the heart and soul of a department is our OBGYN. In our OBGYN residency, we have 16 fabulous residents, so thanks to all the residents. Okay, ready, set, go. Barbie or Oppenheimer?
Oppenheimer.
Bollywood or Hollywood?
Hollywood.
Harry and Meghan or Will and Kate?
Will and Kate.
PlayStation or Xbox?
Xbox.
Mac or PC?
Mac.
Sorry, this is a short answer. What was your first job? What was
my first job?
Yeah, sorry. I should have warned you. Sorry about that.
Sorry. I was a librarian in... I was, yeah. I was terrible at it.
Luckily, medicine worked out.
I
right?
know. I was a librarian, or not. I was not a librarian. I was a library intern in the Library of Maps at Stanford.
Fantastic. Wow, this was a great question then. Cricket or baseball?
Cricket.
Football or soccer?
Soccer.
Sneakers or trainers?
Sneakers.
Yankees or Red Sox?
Yankees.
And ooh, careful. Do you have a car ride to the station, I hope? Because here's a good one. This was from my son, actually. Messi or Ronaldo?
Messy.
Okay, bring that one home. Pickleball or tennis?
Tennis.
What is your favorite breakfast?
I actually don't eat breakfast.
Okay, there you go. That was a short answer. Chess or checkers?
Chess.
Sunrise or sunset?
Sunset.
Ann Patchett or Jonathan Franzen?
And Paget.
Oh, yay. I love Ann Patchett. Oh, that made my night. Thank you.
Don't tell Jonathan.
No, it'll stay
I know
here.
both of them.
Right. What happens in Stanford stays in Stanford, right, folks? What is the title of the last book you read or what you're reading now?
I'm reading G-Man,
Okay.
which is an incredible biography of J. Edgar Hoover. Highly recommend it. It's 800 pages. You can kill someone with it, but yes. But very good.
Or you'll make lots of neuronal synapses by reading it.
Yeah.
All right, we're in the home stretch. Osteoblasts or osteoclasts?
Oh, cute question, but osteoblasts.
T cells or B cells?
T cells, I happen to study them, so yeah.
There you go. DNA or RNA?
RNA because it's more fun.
More fun. And last but not least, genes or cells?
Cells.
Thank you. Great, thanks so much. Appreciate that. Now we're going to go to the audience. So we have microphones, and we're going to ask folks to try to speak in the microphone. We'll try to get to everybody, but the microphone helps with the taping so people can hear the question, although I'll also try to repeat the question. So right here. Let's begin.
Dr. Mukherjee, and I'm so thankful for spending the evening with us, and
My pleasure.
I will be spending my entire nights reading this new book of yours, as I have the last three. I want to preface my question by verbatim stating one of the quotes from your book, The Gene and Intimate History, that says, freaks become norms, norms become extinct, monster by monster, evolution advanced. And about 9 years ago in UCLA's TV network with journalists talk with Mr. Dean Nelson, if I'm remembering that correctly, you had mentioned how research has changed. The regulatory landscape for research has changed in the last 50 years. I just wanted to ask, do you hold that same opinion that you held in that interview 9 years ago? What has changed, or maybe in a better way to say, what would you like to change in the regulatory landscape in this country to advance science further?
Well, so it's a complicated question. I mean, the quick answer is I think the regulatory landscape is always catching up with the science. It's always one step behind because you don't know what's going to come around the corner. I think the regulatory landscape has changed, sometimes for the better. So almost always what happens is that the regulatory landscape changes, it overshoots because of various reasons, including optimism about something, then it has to correct itself. And this happens over and over again. It's a little bit like evolution. And so I think what we've seen in the last 4 to 5 years is the regulatory landscape changing. I'm almost certain that it overshot. It's overshot in a couple of ways. One of them is I think that, for instance, I think a drug such as some of you may have seen this, but a drug such as OxyContin would not have had complete regulatory, went through, I would say, a regulatory process that would not have been really even amenable in the 1960s. I talk in this book about Francis Kelsey, a very important person. So, you have an incredibly addictive, potent narcotic, which is being released into the public without appropriate controls. Would not have happened in the 1960s. And that's because, there was an incredible degree of advocacy plus pharmaceutical pressure that occurred. And we now know the consequences of that. It unleashed a terrible epidemic that we're still struggling to contain. So I think what typically happens is the regulatory landscape changes. The important thing is to learn from the past, is to learn what checks and balances to put into place so that that doesn't happen again. There has been an appropriate uh, resistance to some of these drugs for Alzheimer's disease that were just passed through the FDA. And I think it's appropriate because they're extraordinarily expensive and they have carry risk. And what's happened as a result of that is that people are now saying, well, let's try to figure out who responds and who doesn't respond. Let's try to personalize it and figure out who the patients are who actually do respond. That is the appropriate cycle of response, which is to say that, you know, when drugs get moved without, I would say, without the full regulatory scrutiny, the appropriate response is for you and me, the public and physicians, to say to the FDA, that's just not right. We're seeing things that don't seem right to us. If that cycle had been appropriately exercised for a drug like OxyContin, we would not have this epidemic. That cycle broke. And, you know, I'd recommend people watch the films, the 2 films that are out, about one documentary and one sort of fictionalized documentary, which goes through how that cycle broke. Physicians and patients should have, patient advocates and the regulatory networks should have provided a counterbalance, which they didn't. And as a consequence, we have this horrible epidemic.
Thank you. Dr. Gofrani.
Hi, thank you both so much. That was wonderful and exciting to hear. Dr. Mukherjee, I love that you are clearly a scientist because I think we really enjoy facts, but I equally appreciate that you seem to have a very spiritual side, if I'm discerning that correctly. So I'm curious if you have thoughts on the idea of our consciousness as an entity separate from our brain.
Yeah, I mean, it's a very important question. You know, I think it's a little bit above my pay grade because, you know, certainly I've thought about it. It's a thought that every scientist comes to at some point of time. I think that the quick answer to that question is that I think that there are phenomena that have to do with the way our brains, our neurons are networked together, that create phenomena that wouldn't be even possible to imagine without that network. And I would extend that idea to communities as well. I would say that in communities, and this was the original title of the book, the sum is always greater than the sum is greater than the sum of the parts. You can't add together. It's not a plus. There's a multiplicative or synergistic effect that happens when networks of either humans or neurons get together and begin to encode information or love or community or spirit together. And I think that is probably one basis of consciousness. There may be others that I'm unaware of.
That's your next book, right?
Yeah.
I got a question. Right there, yes.
Oh,
Thank you.
hello. Get ready for a softball question after those. 10 years ago or so, I was astounded to learn about the microbiome and all the effects it had on the body. And
That's your softball question?
yeah,
I'm
it was
joking.
just very exciting to me. And I love to hear what the teachers are interested in learning. So what do you find is the most exciting research going on now?
So, great question, and you know, I think the microbiome's been very underexplored. We are just learning even the tools to understand it, and I would say that there's a whole level of mystery there. As you know, we're as some people have put it, we're just carriers for suitcases for bacteria, and so what's inside us is you know dwarves us in cellular terms by factors of 1,000, maybe 10,000, maybe 1,000,000, depending on the organ that you look at, and so the only thing is that we actually don't know what's consequential and what's not consequential. And so some of it may be very consequential. in terms of what's happening in our guts and our mouths, etc. And some of it may not be very consequential because it just they just happen to be symbiotic commensal organisms that are sitting with us. So I think it's a big unknown, but we finally have the tools to understand it, and I think that's where the science is going.
Great, and I think we have time for one more question, and then I want to give a chance for people to get their book signed. So, in the back.
We know you don't eat breakfast, but I wondered what you do on a daily basis to keep your cells healthy.
Nice.
That's a good question. Well, so I don't eat. It's not that I don't eat breakfast by choice. It's just that by the time I have to run out of the house, I don't have time. And over time, I've evolved a mechanism by which I can probably get to lunch without eating breakfast. If I have breakfast, then I skip lunch. So I try to have 2 meals a day. So what do I do to keep healthy? I think the most important thing in physical health, ironically, is mental health. So before you take care of your body, you need to take care of your mind. If you don't take care of your mind, you'll never be able to take care of your body. So I think the first and most important thing is, and they're related to each other, but you can't get yourself out of bed to, for instance, exercise if you can't get out of bed in the first place. And so the first thing is to create a space for mental health. And then it becomes a self-fulfilling or a cycle. And the cycle is that your mental health leads to better physical health leads to better mental health. So the things that I do is play tennis. That's why I chose tennis. And I run, and I've started walking. So almost every day I'll take about a mile, walk about a mile. I don't consciously eat. I don't consciously diet. But what I do consciously is to stretch out my meals, and I don't snack. So those are my very very broad sweep ways in which I maintain health, but obviously mental health first. Thank you very much.
Great. Well, thank you so much. I'd like to thank Dr. Mukherjee. A lot of fun. Thank you. And thanks to all the friends for joining us tonight. I'm going to defer to the library team, but we're heading this way.
Right over here for signing.
Okay,
Yep.
great. Thank you.